My name is Juliana Resong, and I am a third-year mechanical engineering student at California State University, Long Beach. One of the topics that I am passionate about is health and safety, which isn't always one of the most prevalent thoughts when it comes to design and engineering. Sure, it's a constant concern when building and operating, but the type of safety I would like to talk about today is safety by design. This topic was introduced to me by an engineer at the Los Angeles Department of Water and Power, and it really struck me. By taking into consideration everything from building to operations to maintenance, it ensures the health and safety of everyone involved in the whole life cycle of the project. There are many different names for safety by design, such as prevention by design, as it is called in a Water Research Foundation report. While it's a concept with many names, it's one of the most important topics to consider when starting a new project. Today, I would like to highlight the key points of safety by design and provide a few relatable examples so that everyone can see the positive effect that safety by design can have on the world of engineering. Currently, while in school, I work part-time as a receptionist at a chiropractic office, and I've seen a lot of people with back, neck, and wrist injuries. Workplace injuries are very common and can come from just about anything, from sitting in a chair wrong, to picking something up wrong, to repeating a motion over and over again. As time moves along, we are seeing more standing desks and chairs with proper back support so that people don't have to awkwardly position themselves to look at the computer screen, as well as seeing orthopedic inserts for people who are on their feet all day. Operating equipment for a long period of time can result in repetitive injury from lifting or twisting a certain way that is not natural to the human body. Repeating the same motion can cause significant damage that can stick with someone for the rest of their life, and that's something that everyone wants to avoid. An important part of safety by design is getting the end users involved so that the project is ergonomic friendly. An example of where this could be directly applicable is a manufacturing plant or a power plant. By putting operating valves at belt level, it makes them much easier to operate as opposed to putting them on a platform that requires climbing a ladder to get to. There are at least 3 ways that this situation could cause an injury: climbing up the ladder, climbing down the ladder, and repetitive injury from bending or stretching to use the valves if the platform is not at the right height. The goal of safety by design is to adapt the project to the person, not the person to the project. Most of safety by design is common sense, but that doesn't mean it's not worth talking about. In the same manufacturing plant or power plant example, hazardous equipment and materials could be kept behind grates and screens. There could be splash guards and containment pits for chemicals, and doorways could be widened so that emergency personnel can easily access the building if need be. Another dangerous place to be is in a confined space. It's easier to get stuck and injured. By putting operating equipment at ground level instead of down inside a manhole, it keeps people from going down into a potentially unsafe environment. Along the same line of thinking, having enough rescue exits in important locations and buildings is an important part of safety by design. It takes a significant amount of planning and knowledge to create a project that addresses every single safety concern. Even engineers who have been working in industry for a long time can't see every issue when only considering a 2D design. This is why it's important to design in 2D, 3D, and 4D. For example, designing in 3D helps the engineer see the layout of the project and if there are any potential conflicts in building it. When considering the 4th dimension, time, it also begs the question, are there any potential conflicts when continually operating it? And this is where it is important to have feedback from people who will be using or accessing it continually so that they can provide unique insight. When designing anything, but especially when considering the continual safety of everyone involved, it is important to have design reviews with users. A good way to do this is to have design reviews at certain percentages of completion of the project, such as 30%, 60%, 90%, and 100%. These design reviews should not just be arbitrary either. Sitting down, having a presentation on the design, and making adjustments based on the concerns of the end operators is essential to safety by design. Safety by design works because it eliminates unnecessary risks by designing around them. An exceptional example of safety by design is something that most people use every day: their car. The passenger compartment, the cabin of the car, is designed to be used safely and efficiently. It's laid out for ease of operation while still taking into consideration the airbags and other safety equipment that cars are required to have. However, when you go under the hood of some cars, it can be difficult to work on the engine because it was not necessarily designed to be easily maintained. There is much less consideration in regards to user safety in the engine layout than in the driver's seat of the car. Many people get cuts, scrapes, and bruises from fixing their cars at home, which could be easily avoided if the engines were designed to be worked on. Safety by design would involve changing the layout of the engine so that it's much safer and easier to access. Sure, it might not be as easy to manufacture, but it would help the environment because more people would be willing to keep cars longer and work on their cars themselves if it weren't so risky and complicated. No one can see everything that's going on at all times. Humans are not omniscient. People tend to have specific sets of skills that they've picked up throughout the years, but you wouldn't expect a lifelong chef to know the dimensions of a specific O-ring of a space shuttle, so why are ordinary people expected to be able to figure out what was going on in a 2D drawing by themselves? 3D design helps the engineers communicate the end product with the end users. It helps people visualize what's going on in a way that was only imagined 100 years ago. Design walkthroughs are becoming a much bigger part of the design process when collaborating with the end users because it allows everyone to fully see what the plan is. Safety by design highlights the importance of communicating clearly with the end user and communicating in a way that they can clearly understand and comment on. In the old days, the end user would review the 2D drawings for the project after they were done and approve it because they weren't able to understand it and picture the vision that the engineer had, so they didn't see the future problems that they might have later on. 3D drawings are especially important when working on a project that has many engineers working on their own parts. When just looking at 2D drawings, it's impossible to find every error 100% of the time, because even the most practiced engineering mind can make mistakes. It's only human. When combining the 2D drawings into 3D drawings, it highlights the errors and allows them to be fixed before they become actual problems. It's also important to look at projects in 4D. So, going back to the engine example, it would make sense for the engineers designing it to pull from past experience to help predict what might need to be fixed or replaced more often. By working that into their future design, they could create something that the driver of the car and the repairman of the car can find easy and safe to fix. I don't know about you, but I know I would be willing to spend more up front on a car that had an engine that was easy to work on because the labor repair costs would be lower in the long run. While many companies and institutions have shifted to being focused on safety by design, it's not always expressly discussed. Ease of use and ergonomics are important topics that should be talked about. Humanity is not at the point where every injury can be easily fixed. Not yet, anyway. So it's important to take care of the bodies that we have as much as possible. Preventing repetitive injuries and strain from unnatural movements are essential to maintaining the long-term health that people crave as they age. It may seem fine when you're young, but there's no telling what the effects on the body are. By designing projects with the end use and maintenance in mind, injuries can be greatly reduced, which improves people's quality of life now and as they get older. There are several important points that safety by design makes. First, the goal of safety by design is to adapt the project to the person, not the person to the project. Second, safety by design works because it eliminates unnecessary risks by designing around them. Third, safety by design highlights the importance of communicating clearly with the end user and communicating in a way that they can easily understand and comment on. Lastly, safety by design shows the importance of looking both forward and backward in time when creating a design so that the end project can be as ergonomically safe as possible. Thank you for listening to this talk about safety by design, and especially now, stay healthy and safe.